do you believe in at the end of the day?
I think it's a continuous spectrum from full manual control to full autonomy. And clearly cars have been evolving over the last 5 to 10 years, adding more features that give the driver less cognitive load. Lane assist, speed regulation, adaptive cruise control, all of these things are an evolution towards full autonomy on surface streets. And to be clear, the accessibility goal of Toyota Research Institute is to enable people with disabilities or the elderly to have access to transportation regardless of their physical capabilities, and that implies full autonomy. So that is one of the end goals and the evolution of the technology that we'll be investing in. But we do see it as a gradual evolution where we can deploy these autonomy features, get feedback on them, and then slowly work our way towards full autonomy. But by doing that, by releasing products and testing them and validating them. So I think some companies are aiming for a big step change right away, and it's very, very hard. I was involved with developing the effort at Google, and I do think that the team has made amazing progress, and we will have fully autonomous vehicles in the near future. And I hope that there'll be many, many companies that will be deploying these, because I do think at the end of the day, many lives can be saved, and that this technology will transform our society. And so there's not just one size-fits-all solution, there's many different solutions. I think it'll be a vibrant and active and competitive landscape, as I think it's quite obvious. There's many, many players now getting involved with automobiles, and so it'll be really fascinating to see how the technology evolves, but at the end of the day, I think all of us share the goal of making the world a safer place to drive and a better place overall.
How long ago did you work for Google, and how long did
This
you
is
work
my
for
first week on the job at Toyota Research Institute, and I spent the last 6.5 years at Google. And before that, I was a professor at Carnegie Mellon, working on various robotics projects. And actually, several of the robotics projects I worked on at Carnegie Mellon were with Toyota. So I have a long history with the company, and so I'm very excited about this new opportunity.
Did you work with Red at DARPA?
Red Whitaker was the lead of Carnegie Mellon's team, and I helped with some of the students who wrote some of the motion planning software. That's been kind of my area of research, and when I came to Google and joined the initial group of 10 people to build the self-driving car, my responsibility was the route planning software for that vehicle. And so I'll be working again with many of the team here to help deploy that these kinds of technologies on Toyota's research vehicles, but also to, I'm extremely excited about the opportunity that Toyota can bring to the table with all of its data. It's becoming clear over the last several years that machine learning is going to be and play a big role in perception and understanding, and also behaviors, and dealing with these long tail of rare events that we're going to need to address, as Gil mentioned, the hard part of driving. And we believe that we have a good chance of finding and solving those problems and making safer products because of the trillion miles of data that we hope to exploit.
Isn't it a bit of an illusion to build a machine that will never cause a crash? I've never seen a machine that doesn't make a mistake or break down.
It's a goal. I think it's totally worthwhile and reasonable to have a dream to build a safe and reliable machine, much in the same way that people who are building autopilots for airplanes are working very hard to build them to be safe and reliable and robust. And it's a continuous problem, and it's not easy. But I think that with proper discipline in software engineering and testing and validation, we can build as safe a system as possible, and hopefully, it's not saying that there will never be crashes. It's saying that our systems will not be the cause of those crashes.
Can I ask you questions about camera technologies? And are you based in Bay Area?
Yes.
Okay.
We are right next to Stanford University.
Oh, okay,
Yes.
great. Can I grab your card, please?
Yes, sure.
So if you're in the Bay Area, I'd like to send you an email regarding some camera technology.
What is your what did you take from Carnegie Mellon over to Google in the Google Auto?
We built a software system mostly entirely from scratch when we started the project at Google. So the main thing were the papers and the research algorithms that we published before to implement them in part of a production capacity. One of the things I learned as moving from academia to industry was the difference between research code and production quality code, and code reviews and some of the infrastructure around designing APIs and also deploying them at scale and testing at scale was something that Google had invested in and is very good at. And so that was quite different from my lab. My grad students might say, Professor, I implemented the algorithm, it works, but I know there's a couple of bugs in the code. And I would say, don't worry about it, just publish the paper, right? And unfortunately, robotics researchers have actually made it a lot harder to for industry to deploy products because people have such high expectations, not only from Hollywood and science fiction, but also because you see a video of a robot doing something and it may have been the one time it worked. And what we're going for is reliability and robustness regardless of the situation that it's faced with, and that's very, very hard. And so we're actually not there yet, and so it's going to take quite a bit of investment of both time and money to sort of get to the point where we can deploy products safely and confidently, and so that's a big difference between sort of running the research lab and being on the industry side. And I hope that Toyota Research Institute and the team we're building will be able to bridge a gap between doing cutting-edge innovation research and trying to bring the latest new technologies and algorithms, but then deploying them safely on consumer products and really impacting the world in that way. That's our hope.
So we started today with a bit of a reality check on existing self-driving autonomous cars.